Today we're going to look at section 4.8, quadratic formula. Our objectives are to be able to use the quadratic formula to solve a quadratic equation, to be able to find the discriminant, and to be able to identify the number of real solutions using the discriminant. So what is the quadratic formula? Hopefully this is nothing new for you, but if you are given the equation ax squared plus bx plus c equals 0, then we can solve for x by using the equation negative b, or opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. That's the formula we're going to be using today. But where did this actually come from? I know most of you have just probably known it, but I kind of want to go through quickly the steps of how the formula came about. It isn't some magical formula. Someone a long time ago actually started with completing the square and went from there. This is nothing you're going to be tested on. It's just kind of informational for you to show you why it works. So if you remember from completing the square, the first thing we did for solving is divide everything by a to get a lead coefficient of 1. So I'm going to write this over here. We have x squared plus b over ax plus c over a equals 0. Next step we did was move over our constant and put our plus blank. So I would subtract c over a, and then add my plus blank. Then what I would do is take half of this. Well, if I take half of b over ax, I get b over 2a, and hopefully that part looks familiar, quantity squared. And now I'm going to square that to put into my formula. So I'm going to get b squared over, because b times b, 2a times 2a is 4a squared. Hopefully that looks familiar. So then I'm going to have to add that to the other side, b squared over 4a squared. Okay. Now I know this is equal to negative c. Now what I want to do is, actually I'm going to, right now, instead of writing it out, I'm just going to get a common denominator, kind of help solve this a little bit. So if I want to get a common denominator here, okay, I'll kind of do this off to the side, I need to multiply top and bottom, our numerator and denominator, by 4a. So this is just negative 4ac over, okay, so multiply top and bottom, 4a squared, plus b squared over 4a squared. So now I have a common denominator, so I can add my numerators. So I'm going to do that in the next step. X plus b over 2a, quantity squared, equals, and I'm just going to switch the order, because I like to have b squared minus 4ac, have my minus sign in the middle, over 4a squared. So now what would I do to get x by itself? I'd take the square root of both sides, okay, which was going to leave me with x plus b over 2a equal to plus or minus the square root of our numerator, b squared minus 4ac, over, my denominator is a perfect square, because 4a squared is just 2a times 2a. And now for my last step, I'm going to isolate x. I'm going to subtract b over 2a plus or minus, plus or minus the square root of b squared minus 4ac all over 2a, but I already have a common denominator, so I'm just going to write it as one fraction. Opposite of b, plus or minus the square root of b squared minus 4ac. And I'm hoping that if I actually gave you something like that, you'd be able to go through the steps we did. Now the algebra is a little bit messier, but the process is the exact same for what we did in class on our last lesson, and that's where the quadratic formula came from. So what is this discriminant? Well, the discriminant, and what does it tell us? The discriminant is the b squared minus 4ac part. And this should look familiar because this is the part underneath the radical in our quadratic formula. And what it's going to do, it's going to tell us how many real solutions we have when solving a quadratic equation. Now, if you notice, we're not taking the square root of this number. It's truly just the value underneath the radical. So if that b squared minus 4ac is greater than 0, okay, which means it's positive, then we get two real solutions. Okay. If the b squared minus 4ac is equal to 0, then we get one real solution. And the reason is because if I take the square root of 0, I get 0. There is no plus or minus 0, it's one answer. If I have a positive number and I take the square root of it, I get plus or minus that number, so it's going to give me two different numbers. And if I take b squared minus 4ac and it's less than 0, or a negative number, then there's 0 real solutions, because what we get are two imaginary answers. And the reason they're going to be imaginary is because that b squared minus 4ac is underneath the radical. And if we take the square root of a negative number, we get an imaginary answer. So we're going to go through 3 examples. Hopefully this looks familiar to you. If you remember, the first thing I need to do is to put this as ax squared plus bx plus c equals 0. So I need to first move the 2 over. Set it equal to 0. That's the biggest mistake people make. Just to show you, this is our a value, -6 is our b value, and then the 2 would be our c value. Okay, I always like to write x equals to remind me what I'm solving for. The opposite of b, plus or minus the square root of b squared, I know is going to be a positive 36, minus 4 times a times c, all over 2 times a. Okay, so I'm going to get 6 plus or minus the square root. Okay, this is going to be 36 minus 4 times 4 is 16 times 2 is 32, all over 8. Go up here, I'm going to get x equals 6 plus or minus the square root of 4 all over 8. Now this number right here is called the discriminant. Okay, it's what I get when I do b squared minus 4ac. So the discriminant, okay, is 4. So what does that tell me? See if I can fit this in. Discriminant. Sorry, it's kind of small there. This is a positive number. So what that tells me is that I'm going to have 2 real solutions for this problem. Okay, because that's positive. So let's see what those 2 real solutions are. I'm going to get x equals 6 plus or minus square root of 4 is 2 over 8. Okay, I'm going to get 2 answers. 6 plus 2 is 8 over 8. 6 minus 2 is 4, and then we have it over 8. So my 2 solutions, which are both real numbers, 8 over 8 is 1, and then 4 over 8 is 1/2. So those would be my 2 real solutions. Our second problem makes it a little bit more difficult is because not only do we have things on both sides, but we have to combine like terms. So I'm going to subtract 6x squared and get 2x squared. I know I want the x's next, so I'm going to subtract the 1x I have. Oop, sorry. And then what I want to do is subtract 7, which is going to give me a positive 4. Again, my a is 2, my b is a -1, and my c is 4. So I'm going to go through the steps. X is equal to the opposite of b, which would now be a positive 1, plus or minus the square root of b squared is 1, minus 4 times a times c, all over 2 times a. So I'm going to get x is equal to 1 plus or minus the square root of 1. 4 times 2 is 8. 8 times 4 is 32, all over 4. Okay. X is equal to 1 plus or minus the square root of -31 all over 4. And again, this value right here is my discriminant. And because it is negative, what that tells me is I'm going to have 0 real solutions, because I'm going to have 2 imaginary ones. Now you don't have to tell me the 2 imaginary part, but I just want you to understand it doesn't mean we have no solutions. It just means that they just are not real numbers. So let's go on simplifying. 1 plus or minus. Okay, to simplify this, if you remember, we're going to pull out that I, because the square root of 31 is just the square root of -1 times the square root of 31. But the square root of 31 doesn't simplify, so I'm going to leave it like that. Now, if you want, you can leave it like this, or some teachers and some students prefer to separate it into 2 fractions. 1/4 plus or minus I root 31 over 4. On a test, I don't care which answer you guys give me. Both are acceptable. Let's go to the last example. This one's already set up for us for our a, b, and c. A is -3, b is 6, c is -3. So we're just going to substitute into our equation. Opposite of b is -6, plus or minus the square root. B squared is 36, minus 4 times a, which is -3, and c, which is a -3, all over 2 times a, which is -3. Just be careful with the negatives. So, if I simplify this, -6, plus or minus the square root, 36. This is 4 times 9, which is a 36, but 3 negatives make a negative. And this is all over -6. So if I simplify this, I get negative 6 plus or minus the square root of 0 all over negative 6, which if we look, our discriminant now is a 0. And what that tells us is we're going to get one real solution. And the reason we only get one real solution is because if I simplify this, x equals negative 6 plus or minus the square root of 0 is 0. Negative 6 plus 0 is negative 6, and negative 6 minus 0 is still negative 6. So negative 6 divided by negative 6 gives me just a single answer of x equals 1.